Anyway, let me not waffle on about that. This was your homework, if you remember from last time. I gave you the cos of 165, and you had to calculate its value without using a calculator. So I'm just going to briefly go through that with you. And then we will get started on today's work. So the first thing that you would need to do is you would need to use your reduction formulae. So the angle 165 is in the second quadrant. So we would have used the reduction formula 180 minus. Okay, and it would have been 180 minus 15. So that would have given us negative cos 15, because cos is negative in the second quadrant, and then we would have had to make 15 using special angles and compound angles. Okay, so we can make 15 by saying 60 minus 45. You can make 15 from saying 45 minus 30 as well, if you want to. So that's also another way that you could possibly do it. Anyway, I did it as 60 minus 45, and then I took my negative out. All right, and then I expanded my double angle. So cos 60, cos 45 plus sine 60, sine 45. Then I subbed in my special angles, leaving my negative on the outside. So cos 60 is a half, cos 45 is root 2 over 2. Sine 60 is root 3 over 2, and sine 45 is root 2 over 2. I multiplied my fractions, and then when I added them together, I also took away my brackets. So I multiplied the negative into the bracket so that both minus root 2 and minus root 6 ended up being negative. So my final answer, minus root 2 minus root 6 over 4. How did that go? Yes, we had homework. So yeah, I asked you to do this question. Sometimes I give you homework, sometimes I don't. But I had said to you, go back and go and try this question. Okay, anyway, if you did, you did, and if you didn't, you didn't. It's not the end of the world, but for those of us that did go and try it, those are the answers that we would have had. Who did try this and got it right? Is there anybody that did it and got it right? Can you put a thumbs up in the chat or something? Cool, Sharon. Well done. Nice.
Well done, Sharon.
Good job. Because this was a difficult one. It was not an easy one. Anybody else apart from Sharon that tried it and got it right? Oh, and Nobasutu. Good. Well done. Very nice.
Well done, guys.
Nice to see that.
Nice job.
And Angelique. Good job, Angelique. Well done. Well done.
Batabile also. Nice.
Oh, and
guys.
Batabile. Okay, so there were a few of you. That's really encouraging to see. Well done. Okay, and Shiamo.
Wow.
Well done. That's wonderful. Good work. Okay, so you see, if you just keep practicing and keep trying, these things do eventually start to come right. It's easy for you, Linda and I, because we've been working with this for so long, but we understand the first time you start doing this, it is going to be difficult. That's why you have to keep practicing. Okay, all right. Well, let's get on with today's lesson. We are doing double angles. There we are. And again, we're not allowed to use any calculators. Today, we are going to talk about the basics. Okay, so double angles, like so many things in maths, one thing comes from something else. So double angles actually come from compound angles. That's why we do compound angles first, and then we use the compound angles to understand what double angles are. All right, so the double angle formulae that you're going to be working with are the cosine and the sine double angle formulae. The first one I want to speak about is sine 2a. All right, so in order to understand what sine 2a is, 2a comes from a plus a, just as I've indicated over here. All right, so that's why we call it a double angle, because we've taken a and we have added it to itself. Okay, so where does this come from? Well, if we work with our sine compound angle formulae, so in other words, if we're looking at this over here, if I work with sine A plus A, this is what happens. Now, this is using my compound angle formulae. Okay, so it would end up being sine A cos A plus cos A sine A. That's using my compound angle formula. And when I look at these two terms, I notice that they are like terms. Okay, they're both sine A, cos A. So I can add them together. So that gives me 2 sine A, cos A. All right, so that's why we say that sine 2A, which is sine A plus A, is 2 sine A cos A. That's where it comes from. Everybody happy with that? Thumbs up, thumbs down? We've okay with that one? So and that's very easy. So whenever we see sine 2A, we're going to expand it and we're going to write it as 2 sine A cos A. All right, there's no other alternatives for that. That's all there is. That's all there is to it. Okay, cos 2A is a little bit different. Okay, so cos 2A is formed in the same way. All right, first of all, it comes from a compound angle, and then from there we have our new identities being formed. Okay, so if we use our cosine compound angle, we would end up with cos A plus, oh, sorry, beg your pardon, it's not plus, because cos doesn't keep its sign, minus sine A sine A. Okay, so that's again, I'm using compound angles in order to do that. So when I multiply cos A with cos A, that's how come I get cos squared A. And similarly, sine A times sine A gives me sine squared A. All right, now from there, we are able to use our square identity, and nobody's going to ask you to derive these. I'm just explaining to you where it comes from, okay? So in grade 11, remember we learned about the square identity. Sine squared A plus cos squared A equals 1. We all remember that. And then what we can do is we can either make sine squared A the subject of the formula, or we can make cos squared A the subject of the formula. So if I make sine squared A the subject of the formula, it would become 1 minus cos squared A. So what I'm going to do is I'm going to replace this sine squared A with what it is equal to over here. So in other words, I'm going to substitute in 1 minus cos squared A for sine squared A. So if I go ahead and I go and do that, this is what happens. I end up with cos squared A minus, I'm going to put brackets because I am substituting, 1 minus cos squared A. I touched the button on the side of my pen again. Okay, removing the brackets now, I've got cos squared A minus 1 plus, because a negative times a negative is a positive, cos squared A. And again, cos squared A and cos squared A are like terms. So this is where 2 cos squared A minus 1 comes from. Okay, so there are many ways, well, 3 ways, not many, in which we can write our cosine double angle. So the first one is what I'm highlighting in yellow. So cos squared A minus sine squared A. We can also write it as 2 cos squared A minus 1. Right. There's a third way in which we can write it. So going back to what I had originally here in the second line, I had cos squared A minus sine squared A. Going back to that, actually, I don't need an equal sign there. What I'm going to do now is I'm still going to work with my square identity, but instead of making sine squared A the subject to the formula, I'm going to make cos squared A the subject to the formula. So that's going to be 1 minus sine squared A. All right. And now I'm going to do the same thing. I'm going to substitute. Only now I'm substituting 1 minus sine squared A in place of cos squared A. So instead of cos squared A, I'm going to write 1 minus sine squared A minus, I'm going to bring down that next term, sine squared A. And that's how I end up with 1 minus 2 sine squared A. And that is the third way in which I can write my cosine double angle. Okay, so there are 3 variations. All right, and you'll see when you look on a formula sheet, all 3 are given to you. Okay, so it would look like that. Okay, so on your formula sheet, you will see sine 2a equals 2 sine a cos a, and then they will also tell you that cos 2a can be equal to any one of those 3. Right. And it matters which one we use eventually when we get to identities and equations. But certainly when we're doing Pythagoras and ratio in terms of a letter, it does not matter which cosine double angle expansion we end up using. Okay. I see there was a hand up. Sibongenhle, go for it. Did you want to ask a question?
Yes, please, ma'am.
Sure.
Ma'am, I wanted to ask, so when do you know which way to use? Because you said there's 3 ways, and
Yes.
it's
So
just up to us, or
it is. But I say yes, it is. But when we do identities, okay, so proving identities, and when we do equations, then there are some tips and tricks on which one to use. But if you are doing questions on Pythagoras, so when you're working on the Cartesian plane, or when you're doing questions on ratio in terms of a letter, then it doesn't matter which one you use. Okay, but as soon as it begins to matter, then I will point it out to you what it is that you need to do. Okay.
yes, ma'am. Thank you,
All
ma'am.
right, no problem, no problem. So in this lesson as well, Sibongenhle and everybody else, we're not going to worry about any calculations. We'll do that in our next lesson. Today, we're just going to become comfortable with expanding them and then doing the reversal of the expansion, just like we started off with compound angles. So nice and easy. Okay, and again, this is not something that they will question on its own. Everything that you do will be the application of this. All right. Unfortunately, the questions are not this easy. I think that's one of the reasons why we also find trig so difficult. Okay, so let's have a look at some examples on how we would use this to expand them. And we've got angles, and we've also got angles with letters, and then we've also got angles that are numbers as well. So let's go through these together and see how we use them. All right, so I'm going to start off with question A, number 1. They have given me sine 4a. So not sine 2a, sine 4a. And sine 4a is a double angle. This is what I can do with it. I can write it as the sine of 2 times 2a. Now, the emphasis here is this. 2a is your angle in this case. All right, so because this is a double angle, I can now use my sine double angle identity, and I can write this as 2 sine 2a cos 2a. All right, so I've expanded it like that. That could be expanded a little bit further, but for the purposes of this exercise, we're going to leave it just like that. Okay, now let's have a look at what happens when we have numbers. All right, so the second example over here is the sine of 50. Okay, so 50 is a even number, so it's very easy. It's 2 times 25 degrees. So again, when I expand it, I would write it as 2 sine 25. So 25 is my angle. Okay, so 2 sine, let's just get a pink pen back, 25 cos 25. Okay, are we all good with that? Is it making sense to everybody? Thumbs up, thumbs down, how do we feel? We okay? So we're just applying our double angle formulae and doing expansions. That's it. Okay, just simple, simple expanding. Okay, is everybody all right? Okay, siamo, because it's part of our identity. Okay, going back to here. Okay, that's where the cos comes from. Okay, so sine A plus A is sine A cos A plus cos A sine A. So that's why it's equal to 2 sine A cos A. All right, it comes from the identity. Okay, I know you're going to ask that a lot. Okay, it's a very, very common question with the matrix. Why is there now suddenly a cos A in there? All right, and then it's because of the identity. Okay, now for one that's a little bit more difficult. Okay, so typically we think of numbers that are even as double something, but one is also double something. All right, what is one the double of? Zentle, what is one?
It's the double of a half, ma'am.
It's the double of a half. Okay, so now we've got sine A, and just as you said, sine A can also be regarded as a double angle. Okay, so in order to be able to do this one, this is how we have to manipulate what it is that we see. So it's 2 times something, and as Zintle said, it's going to be 2 times a half, which gives us 1. So again, I'm emphasizing to you now, your angle is half A. So now when you do the expansion, you're going to end up with 2 sine half A cos half A. Okay, good. Oh, a lot of you said it's double half. Okay, very nice. Well done. Okay, so that's an important one to remember. This comes up in questions that are slightly more challenging. All right. Okay, let's have a look at the cosine double angles. So let's go down to question B now. Let's change our color. And let's do B number 1. So again, they've just asked us to use the double angle formulae of cosine to expand the following. So they give us the cos of 6a. So 6 is an even number, so it's easy to write a double of this. And it is the double of 3. So our angle would be 3a. All right, does that make sense to everybody? Because 2 times 3 gives us 6. Okay, so 3a is your angle in this case. Now you can choose. You've got 3 ways in which you can write your answer. All right, so what I'm going to choose to do over here is I'm going to write it as cos squared 3a minus sine squared 3a. That would be one option. If I wanted to, I could write it as 2 cos squared 3a minus 1 if I liked. And then my third option, if I was feeling like writing that as well, I could write it as 1 minus 2 sine squared 3a as well. Okay, so in the beginning, we just want to become comfortable in writing out our identities and then using the correct angle. Is that okay with everybody? Thumbs up. Is it making sense? Are we all happy? Thanks, Boche, Bositimbile, Tato, Siamo. Okay, Asanda, you guys are all okay with that. Well done. Perfect. Sharon, just say that again. Why it's squared. Okay, you mean cos squared 3a minus, oh, why they're all squared. Okay, so again, it goes back to where the identity comes from. It comes from all of this. Okay, so cos a times cos a is cos squared a. And sine a times sine a is sine squared a. Right, and then we can use our compound angle identity to do those substitutions I was talking about earlier. Okay, so that's why these ones are all have got squares in them. All right, and then I see there's a hand up, Zentle. You're welcome
Sorry,
to ask.
ma'am.
No, don't say sorry.
I was going to ask, ma'am, would there be a time we would need to prove the angles, whether how they came about? The
No.
identities, I mean.
No,
Oh,
no. So they wouldn't. They're not going to ask you. There are times where they ask you to derive things. They are sometimes they ask you how the compound angles are derived, but they don't ask you how the double angles are derived. I just decided to do that so that, you know, instead of you just being told that this is what it's equal to, you actually understand where it comes from. I think that things are easier to understand when we see the reason behind why they are the way they are, rather than just learning something because your teacher told you to or I told you to. Okay, but no, they won't ask you for how these are derived. Okay, and then cos 80, so that's there to show us what happens with numbers. So this would be the cos of, instead of me talking, I'm going to let somebody else tell me what this would be. What should I write inside brackets here, Matrix? Can anybody tell me? Does anybody want to unmute and tell me what I should write here? Go for it, Lisa.
It's gonna be cos open bracket 2 times 40 degrees.
Awesome. Keep going.
Equal to 2 cos squared 40 degrees minus 1.
Cos 2 squared 40 degrees minus 1. Okay, so then here I just mustn't forget to put the 2 in the front. Okay, I don't know if you said that. So 2 cos squared 40 degrees minus 1. I think you did. I just didn't write it.
I did.
Yes, you did. You did.
Yes,
Okay, well done, Lisa. Perfect. Okay, so that's fine. If you wanted to write it in a different way, you could also write it as cos squared 40 minus sine squared 40. Okay, and then the third way that we would be able to write this would be as 1 minus 2 sine squared a, like so. Okay, good stuff. And then just like with sine a, cos A can also be treated as a double angle. So just like with the previous one, we can write this as cos 2 times a half A, like so. Whoopsie daisy. And that would give us cos squared half A minus sine squared half A. Or if I wanted to use the other two, I could write it as 2 cos squared half A minus 1. Or lastly, I could write it as 1 minus 2 sine squared half A, like so. Okay, is that all right with everybody?
Ma'am,
Yes,
you
Tiamo.
forgot to put the 2 at the first, the second answer, at number 3.
Where did I forget to put the 2?
At cos squared half A minus sine squared half A.
Okay, there's no 2 there, not with that one, because it's cos squared A minus sine squared A. There's no 2 in this one.
Okay, ma'am.
Okay, all right, it's just cos squared A minus sine squared A. Okay,
Yes, ma'am.
all right, that's fine. You'll get there. All right, we'll all get there in the end. I know when we first start seeing these, they can be a little bit Intimidating. Okay, so here are some for you to try. What I think I'm going to do is let me just grab that and move this down here, and then at least you've got this
I think that
to
will really help.
refer to. Absolutely. I'm just going to make it a little bit smaller, and I'm going to put it on the side there. Okay, all right. So Matrix, you are going to do exactly what I have done as well. Okay, you're going to expand the sine and cosine double angles using the formulae. Okay, so there are 3 questions here for you to try. I would suggest trying all 3. Okay. All right, so off you go. And if you've got any questions, Yolanda and I are here to help.
Yes, and please stay muted so that we don't hear the noise, the background noise. That's all. Anati, if you can mute for us, because I can't mute you on my side. I think majority of you will love Trig after this, because it's such a good, for me, it gives me like a challenge, especially if I have to prove things or do things like this, because you know, you need to change it. It's more of like art in a way. I love it.
Yeah, Trig certainly is a challenge with regards to that, because you're constantly rewriting things in a different way.
Hmm. Wow, Yala on fire. You're already nearly done. Wow. With B, E, H, or all of them?
Okay, so we'll definitely go through all of these. Don't worry, Zentle. Dikeledi. Okay, so Dikeledi, I don't know if it's a little bit difficult to see, but in B, it's not 60, it's 6 theta. Okay, I don't know if, oh, wow. H is a little bit tricky. Absolutely, that's fine. Okay, so most of you seem to be finished with this. So let's go through them together just very quickly. All right, so I'll fly through B and E, and then we can talk about H a little bit longer. All right, so as far, mind you, actually, I shouldn't do all the talking. I should get you guys to do some talking as well, because we love hearing your voices instead of just hearing my silly voice all the time. Okay, does anybody want to do B first? Yeah, go for it, Cynthia.
So for B, I said it was sine open brackets 2 into 3 theta close brackets is equal to 2 sine 3 theta times cos 3 theta.
Oh, whoopsie, I left off the 3, but there we go. I slipped it in. Brilliant. Perfect, perfect, perfect. Well done, you. Okay, very nice. Excellent. Well done, Sinclair. Who's going to do E for us? Any takers? Amu. Okay, go for it, Amu. All yours.
I said cos into open bracket 2
Mm-hmm.
into 10. Then you close the bracket. And then I said 2 cos squared 10. And then 2 cos squared
So 2 cos squared 10 minus 1.
1.
That's it. Good. Well done. Good. Excellent, Amu. That's brilliant. Brilliant, brilliant, brilliant. And maybe somebody else said something different, which is also okay. So if you said 1 minus 2 sine squared 10, that's also fine. And then, of course, our third option was to say cos squared 10 minus sine squared 10. Okay, so any of these 3 over here are perfectly acceptable. Okay. All right, let's see. I tried H, but you're not confident. You know what, Lisa? It does not matter. I promise you the most important thing is just to give things a try. I think we place so much emphasis on getting stuff right that it kind of almost stops us from giving things a go because we're scared that we're going to make a mistake. If you make a mistake, so what? We can fix it. We can fix it. It's not the end of the world. Okay, so again, I'm going to open this one up. Who's feeling brave and wants to do H? Oh, Tiamo. Okay, go for it. Go for it, Tiamo. What did you say?
Okay, ma'am. At H, I said 2 cos bracket 2 and then 11 degrees. And then I
Mm-hmm.
closed the square bracket. And then I times the 2 in front of the cos with the 2 inside the bracket, and I wrote 4 cos 11 degrees minus 1.
Okay, so 2 times 2 cos squared 11 minus 1. Brilliant. So you would have ended up with your final answer?
4 cos squared 11 degrees minus 1.
Beautiful. Well done. Okay, so what happened over here? All right, so this 2 times 2 over here, this bit over here, so let me just show you what's going on. This bit over here is from the identity, okay? That's from here, okay? This 2 that we're multiplying it by in the front, that 2 over there and this 2 over here are the same 2. Okay, so that's why it ended up being 2 times 2. I hope that's clear to everybody. Okay, you got it. Good. Well done. Very nice. Okay, that's lovely. Well done. All right, so again, the other ways in which we could have written this if we wanted to. Okay, so we would have left our 2 on the outside, and we can write cos of the double angle as sine squared 11 minus cos squared 11. So that would be, sorry, cos squared 11 minus sine squared 11. So another way in which we could have written this would have been as 2 cos squared 11 minus 2 sine squared 11 if you wanted to. That would be another way you could write it. And then the last way in which we could write this question would be using sine squared a. All right, so it would have been 2 times 1 minus 2 sine squared 11 would be the last option. So if you wrote it this way, you would have ended up with 2 minus 4 sine squared 11. Okay. All right, you just didn't multiply the 2. That's okay. That's not the end of the world. Okay. Does that make sense to everybody? Are we happy with that? Are there any questions? Just scroll up a bit. Okay. Is that better or more? Scroll up more. Okay, got it with the second method. Okay, perfect. Okay, so remember, not all, you don't have to do all 3 of these. If you just did 1, then it would be okay. All right, so Sandiswa, I see you wanting me to explain this again. What I'm going to do is I'm not going to worry about explaining the bit in purple. Okay, as long as you understand the one in green, that's more than enough. Okay, so what they're asking you to do here is they're asking you to take the double angle and times it by 2. All right, so you've got, so you put your 2 on the outside. Let me just rub that out because it looks a bit messy. So what we could do is we could leave our 2 on the outside. All right, and then we know that cos 211 ends up being 2 cos squared 11 minus 1. Okay, so now we've got to distribute the 2 into the brackets. Okay, so we would have ended up with 4 cos squared 11 minus, sorry, I think I forgot to expand my brackets correctly the first time, and then it would have been minus 2, like so. Okay, so don't worry about this one over here and that one over there. In fact, if you just ended up with this first line where the green arrows are, that's absolutely okay as well. All right, let's go on and have a look at something else. All right, so now what they're asking us to do is the reversal. So we've taken the sine of a double angle and expanded it, and the cos of a double angle and expanded it. So now they want us to do the reversal of the expansion. So these ones are not too bad, certainly the first ones anyway. So in a number 1, they've given us 2 sine 3 theta cos 3 theta, and they want us to write this as the sine of a single angle. Okay, so we recognize that this is the sine double angle expansion. And now going back the other way, we would write this as the sine of 2 times the angle, which is 3 theta. Okay, so this would give us the sine of 6 theta, like so. Right, so without me telling you, is there anybody who would like to try number 2? Just give it a bash and see what happens. Anyone feeling brave? Does that one look scary?
I'm sure there's someone who has tried. Sharon, do you want to give it a try? How did you get that?
Okay, so what, first of all, let me ask you this. What does A over 2 mean? What is A over 2 the same as? Does anybody know? Let's see what you guys are saying in the chat. There we go. There you go. There you go. Of course, you guys know this. So it's the same as half A, isn't it? Good, well done. So maybe that makes it a little bit less scary. So we've got 2 sine half A cos half A. I'm going to write it like that for you guys. So now when we do the reversal of the expansion, we're going to write it as the sine of 2 times half a. And you guys all know what 2 times a half is. It would give us 1. So our final answer would be sine A. Can you see how we're doing the opposite of what we did before? So I used these same examples up here. So we worked with cos 6a before. We worked with sine A before. We're just doing the opposite of all of these. Okay, I hope that is coming through loud and clear and it's making sense to all of you. Yay, well done, Fahim. Excellent. Good job. Good job. Okay, now for number 3. Number 3 again is a little bit of a trickier one. Let me explain to you what's going on over here. Okay. So they've given us 4 sine x cos x. And when Yolanda and I were saying that trig is about rewriting things in different ways, you can see how that's constantly what I'm doing. And what you guys are doing as well. You're rewriting everything that you see, you're rewriting it in a different way so that it has the same meaning, but so that it can be manipulated or changed somehow and written as something else. So the trick to this one is splitting up the 4 into 2 times 2 and then writing your sine x cos x after that. This over here that I'm drawing the purple circle around, that is your sine double angle. Only it's being multiplied by 2, the first 2, the 2 at the front. So we're going to leave this first 2 here at the front, and we're going to write 2 sine x cos x as sine 2x, like so. Does that make sense to everybody? How does that feel? Thumbs up, thumbs down. Okay, so Nobasutu's happy, Tando's happy, Bochepo's happy, Vayo's happy, nice to see. Nolwazi, lovely, got stars in your eyes. Sibongentle says no, not happy. Okay, Pinder and a couple of other people, Taba Singh. Okay, all right, that's fine. So there's been a request to re-explain that. I'm more than happy to do so very quickly. Okay, so let's get rid of this and let's just go through this again. All right, so what we are doing here is we are focusing first on the 4. All right, remember our sine double angle identity, okay, when it's been expanded. So in other words, sine 2x is 2 sine x cos x, isn't it? Okay, so what we want is we want to try and create 2 sine x cos x so that we can do the reverse of this expansion, so that we can go that way. That's why we split up the 4 into 2 times 2. So it's 2 times, and then I'm going to write this in a different color. 2, so 4 is 2 times 2, and now I'm putting my sine x cos x at the back. This over here is your sine double angle expansion. Okay, but it's going to be doubled. When I say it's going to be doubled, I mean it's being multiplied by this 2 at the front over there. So 2 sine x cos x is sine 2x, but it needs to be doubled. So that's why it becomes 2 sine 2x, like so. Okay, so this bit over here that I've done a purple ring around, that's that one. This is where this comes from. This is this from our identity. And I'm doubling it. I'm timesing it by the 2 at the front. Okay. All right, so Pinda's a little bit happier. Hopefully Sibongenhle is a little bit happier, and Travis is as well. Okay, so good, Sibongenhle. I'm glad that's making a bit more sense to you. All right, and then we can do the same thing when it comes to the reversal of the cosine double angle expansion. All right, we've just got to look carefully at what it is that they have given us. Okay, so in the first one, B number 1, they give us cos squared 2 theta minus sine squared 2 theta. So 2 theta is our angle, all right? We know that cos squared theta minus sine squared theta is our cosine cosine double angle. So I can write this as the cos of 2 times my angle, which is 2 theta. Okay, so this becomes cos 4 theta. Okay, that's not a bad one as far as double angles go. Right, if we have a look at the second one, as far as double angles go, also not too bad. They've given us 1 minus 2 sine squared 2 theta. So 2 theta is our angle. So this becomes cos 2 times 2 theta. All right, so this would also be equal to cos 4 theta. And then the last one, they've done a little bit of a dirty on us. Okay, they've made the last one, again, just a little bit more difficult. How are we all feeling so far? Is this making sense as far as the cosine questions are concerned? Are we happy? Yes, okay. We're saying yes, we're happy, all good, all right. Okay. Hang in there, Travis. I know that these can be confusing at first. And you know what also is difficult for me as well is that I'd love to show you the identities on the page at the same time, but it just ends up being so much on one page. So if you've got those identities next to you, you know what is a good idea? Is that in all future lessons, if you guys can get yourselves a formula sheet and keep your formula sheet in the book that you are currently working in. All right, and then at least you've got that formula sheet to refer to at all times, and you can look at these formulae while I'm doing it. Okay, I think at the beginning this really helps as well. Okay, now they've done something nasty to us in number 3. And again, I suppose this is where it would help us to go and have a look at this guy over here. So let's just copy that. I know it's going to be a bit much on one page, but let's try and squeeze it in here. I'll tell you what, I'm going to move myself out the picture because that's not important. Okay, I'm going to scooch this over a little bit and do it on the side here. If you compare, now what I want you to do is make a comparison matrix. Okay, so look at this that I'm highlighting in turquoise, which is the question. And now look at your cosine double angles. Okay, so you've got that expansion, you've got this expansion, and you've got this expansion over here. Which one does question 3 look like? Which one does question 3 look like? The first one, option 1, absolutely. It does. It looks like the first one. But what's the problem? And I say problem in inverted commas. It looks like the first one, but how is it different? How is it different? Quite right. Option 1. There we go. Cos squared theta is negative and sine squared theta is positive. Absolutely. Absolutely. So what do we do in a situation like this? Yeah, it starts with sine instead of starting with cos. So what do we do in a situation like this? There's something that we're allowed to do to our expression There we go. We can put in brackets. Good, Sibongenhle. So we put in brackets, and what do we take? Ah, there we go, Nhlanhla. Lovely. Yes, Jeanette. Take out the net. Yes. Good, Nolwazi. Good, Nadia. Lovely. We're going to take out the negative. Okay, so again, we are manipulating, we are changing what we see so that we can get it into the correct expansion so that we can do the reversal of the expansion. Very nice. Rearrange and bracket. Absolutely. Okay, so let's go ahead and go and do that. They gave us sine squared theta minus cos squared theta. So we're going to take out the negative and we're going to put a bracket. We're going to move the cos to the front. We're going to move the sine to the back, and that needs to be negative as well. Okay, so if we were to multiply the negative into the bracket, we would end up with positive sine squared theta minus cos squared theta, like so. Okay, so this is a switch round or taking out a negative, whatever you want to call it. Now we can see that what we have here in brackets now looks identical to our first cosine angle extension. Okay, so I'm rubbing the other two out. We can see that this over here, let's get up there, is now identical to that one over there. All right, so it is our cosine double angle, only now it is negative. Okay, so we would write this as negative cos 2 theta. Okay. All right, because it's negative because they want you to factorize. Okay, they want you to take out the negative. All right, so it's like if you have something like this, if they give you x minus y, and you need to take out the negative, then you would write that as y minus x. That's essentially what we've done. Okay, if we look at it algebraically. All right, how are we feeling now? Is this making sense? Are we good? Thumbs ups? Are we feeling happy about all of this? Thank you, Sibongenhle. Good, Maseko. Good, Sandisiwe. Good, Faheen. Nice, Sarah. Okay, Zintle, the last one was easier for you. Oh, cool. I'm glad to hear that. All right, so there was a question, Zintle. Do you want to ask?
Ma'am, this is not related to this, but it's related to the quiz question that I was answering the other day. Can I ask?
Sure.
So the question was, simplify 180 minus x, and I answered that it was sine x since it was on the second quadrant, right? But then when they corrected the answers, it was cos x, and I didn't understand how it was cos x since cos in the fourth
Maybe.
quadrant.
Yeah, maybe that was a mistake. I didn't set the quiz, so I'm not exactly sure which question you are referring to. Which question in the quiz was it?
I think it was the second question, ma'am. I'm not sure though.
Okay, all right.
Sorry, I normally check the quizzes. So did you do the quiz that you were supposed to do today already?
No, ma'am, not this one, not for today. I think it was last week.
Oh,
Yes.
yeah, it could have slipped my mind, but yeah, I'll definitely go and have a check again. But yeah.
Thanks,
Yes.
Yolanda. Okay, so
Thank
Yolanda
you.
will go and check and then we'll talk about it at the beginning of next lesson. Okay, sorry about that, Zintle. Okie dokes, let's carry on.
We have about 1 minute.
Oh, we do. Okay, we do. We only have about 1 minute. Okay, so there's no ways that we're going to be able to get through any of these in the amount of time that we've got left. We can sit and talk about this sort of stuff forever and ever and ever. What I'm going to do is, Shame, this was to give you guys a little bit of practice with this. Okay, so let's do it this way. Okay. Take a screenshot of what's on the screen at the moment. Okay, take a shot of what's on the screen at the moment. I know that there are 5 questions there. All right. And let's do this as our homework for the next lesson. All right. So I'll put up the answers to these at the beginning of the next lesson. What you are doing is the reversal of the expansion. Okay, so you're going to either write it as the sine or the cosine of a single angle. Over here as well are your formulae, but if you look at any formula sheet, you'll get them as well. So let's try those for homework, and we'll talk about those next time. Okay, because yeah, we also need to leave you guys a little bit of time to go and do the quiz as well. Okay, so this is your homework for today.
Nice job, guys. Well
Okay,
done.
well done, everybody. Thank you so much for participating and for sharing your answers with us. I hope that this made things a bit easier for you when it comes to expanding and doing the reversal of the expansion. Okay, it's a pleasure.